Okay, so the last thing we did on Tuesday, we were looking at an antenna type of situation where a single conductor would be just open-ended, floating. They call that a tri-state actually in microcontrollers, and it generally acts like just an antenna. It's going to receive pretty much everything, all of the EMI that happens everywhere, and we've noticed that, we've found that. So that's actually kind of a good thing, so we can learn how to get away from it. Okay, good. Yeah, hopefully my my voice will drown them out. It only happens every Thursday, so unfortunately it'll happen one of the 2 days that I do CNC stuff. But 1 o'clock, I think they're kind of like mellowed out a little bit because they generally start a lot earlier. All right, so I'm going to put on another camera here so you can see generally the overall room. Hopefully that will work out. Hello. All right, so currently we have nothing on this line. This is the one that's going to the motor, and I'm thinking about putting one line here and one line here, which I already have. You can see the green line, but so far we've seen what happens with the turning on of the router, and nothing seemed to happen except we're just getting the AC signal from here on this line, but there isn't any disturbance on the line from the router itself. So I think the only thing to do really, and we found out that there is some disturbance from another video, so I'm really confused about that. So I want to try something else. I'm not really sure what yet, but maybe the chat can help me out. But I want to try to get some spikes like we had before. Maybe it was because we were using a shorter conductor, and maybe this is just so long that all of it is getting shown from the AC line instead. So maybe the AC line is too, it's sort of drowning out any spikes that could happen here. I remember the spikes being pretty big though. So what I want to do here is sort of, I guess the plan. You know what? Hold on a second. My topic hasn't changed. Let me change that. Yeah, we had a little discussion about that, my wife and I. She was all right. She understands the importance of doing these live streams. All right. Okay, I'll call this CNC shielding experiments. All right, that sounds good. Unless anybody else has any other suggestions on the random experiments we can do. Right. Yeah. All right. So let's see here. Oh, I also wanted to try it with the Ryobi, because the Ryobi is oh, look at this. This thing is all, I'm going to take this off actually, because this is going to be dangerous. You see that? Imagine, oh, this doesn't even turn. This may not work at all. But I have a couple more actually. That's interesting. I'm going to see if I can figure this out. I'm going to get my handy dandy Knipex pliers, if I can find it. And I cannot find it. Well, I'm just going to try to turn it and see if it turns. This thing is not, oh wow. Oh no, now it's loose. Oh man, it sounds bad. Oh, look at that. The whole thing is loose. Well, first I'm going to take this thing off. Yes, I'm fine. Not walking with a limp. That is one thing you have to, you definitely have to respect the woman of the house. If she wants to do vacuuming, you got to let her do vacuuming. I mean, I don't really need this anyway, so just put another spanner on here. But look at this. This is bad. Yeah, I think I'm going to throw this one away. Except for the bit, of course. This is a sharp bit. Huh. Oh, you can hear it too. Can you hear that? I think the days are over for this Ryobi. I used to run these Ryobis pretty hard in CNC machines, but this one I used probably to clean up, oh, look at that, to clean up holding tabs and things like that. Yeah, let's do a teardown. I wouldn't mind doing that. Let's see what the insides of these look like. I've already taken my little, what is the brand name of that one? This one I've taken apart, actually. Actually recently. It's the Makita. And the fan was broken inside. There was a whole bunch of pieces of fan blade. So I took it apart. This is relatively easy to take apart, actually. It was very nice. So I definitely recommend this type of router. It's well built, but the only problem is you know, the fan blade may crush on you. And the reason why is because I have this like this, and I'm constantly routing, you know, things in this position, like getting holding tabs off and cleaning up edges. And pieces of debris go into the router if I'm not using it, because if there's debris on the table and I'm like cleaning it up, some can fall in here, because generally when you're routing, the air goes up, so nothing will come in. But when you're not routing, things can fall in, and I think that's the culprit from mine. It's not plugged. All right, so let's see what we have to do to get this thing apart. Let's see if I can get this off. This thing has been on here for quite a while. It doesn't seem to be releasing, so I'm going to get a screwdriver here. Yeah, that would be a good idea, but I could just like, yeah, you're saying 3D print a cover. I could do that, probably should do that. The hole for that is over here. Let me show you. I just have it on a wooden table. That's where it goes, right here. So just the bit comes up out of this, right through here, and I just use this table. That's why I have these holes here. This is another router. This is a bigger router. I think this is another 3 horsepower. I use this to collect the dust while it's routing, because I get a lot of dust, and then the part will lift up because of the dust. So by creating this, it makes a place for that dust to settle, so my part stays very flat. But I definitely should create some kind of cover for it, for sure. Or I could just be neater and just vacuum it. Yeah, for sure. All right, so let's get this off. Oh, it's coming off now. Oh, look at that. It's this right here. That's why. There we go. It had a lock right here. There's definitely something in it. Of course, I wouldn't want to try to turn it on in this state. You can see this is gone, whatever this was. Oh, look at that. A ball bearing. Ha! Check that out. A ball bearing just fell out. So a bearing is completely gone. I could probably just replace the bearing, but I don't know if I would want to do that with a Ryobi. All right, I'm going to need to get an extension for this. I'll try taking this off first. This is a really good screwdriver. It's a Husky, and if you can hear it, this thing is old. It's been on my boat, my sailing boat, in the constant weather and in salt water, and it doesn't sound as good as brand new, but it's definitely held up quite well. I'm going to make this chat a little bit bigger so I can see it while I'm working. Yeah, try to find that bearing that's inside of it. That'll be very interesting to see what bearing, or how the bearing failed, actually. That would be more interesting. Because the bearing, if the balls came out of the bearing, then the seal came off of the bearing, if it even had a seal. But just for that to happen, the races would have to be broken. Well, that was easy. That was a lot easier than I expected it to be. And there is a, huh. Is that a wire? Why would there be a wire there? It looks like there's a wire right here. Right here. I'm not sure what this is, but this is what's keeping it in. I mean, I'm not going to be using this anymore, so I'm probably just going to cut it. My handy dandy side snips. All right, here it goes. Bye-bye. So what would that be? There's definitely wiring in here. Where am I going here? What could that be? What would be wired in the face? Maybe a sensor of some sort. And what would it be? So there's a fan here. The fan looks like it's actually in pretty good shape. This is the blower. All right, so this is part, oh, this is just a shim. Well, no, this is the bearing. So the other part of the bearing is right here. So this thing got torn up. Yeah, this is all, there's the bearing race in here. And this is the outer race here, and this is the inner race. Yeah, well, maybe it is an LED light, but I don't see anything on the other side. Oh, wait, yeah, you're right. LED, LED. There's two LED lights here. So, yep, there we go. LED light and LED light. Very good. Nice. Yeah, I would never even use an LED for this because I would use it under the table or something. All right, so let's see if I can take this armature out. Of course, with my hands without gloves. Yep, it's coming. If you see blood, you'll know why. Got it. Okay. A standard armature, nothing special. We got a little cheap bearing on the end here. Looks like probably a 605 or something. Let's see, or 608, I mean. Let's see what this is. I can't even read it. Yeah, I don't know. It's probably a 608. It looks like a 608. This is, let's see what diameter this is. If it's an 8 millimeter diameter, then it's probably a 608. Yeah. 7.51. I can never know what angle to put this on. So 7.64. It's generally an 8 millimeter shaft. All right. So all I would really need to do if I wanted to salvage this thing, there are the brushes down here. Let's take the back off. Oh, look at all the balls coming out. More balls. There were like 4 balls that came out, but I'm sure the other ones are just gone. Oh, there's more. There's still more in there somewhere. It's good to probably do this to see if I can salvage anything as well. Not that I really would care to, but I'm not sure what I would use used components of a router for unless I had another router that I needed to repair. And I don't think I have another Ryobi. I generally don't like the Ryobi name. And these Porter cables are also made in China too, so can't really win. All right, look at all the dust. There's a lot of little, this is probably MDF, not the MDO that I usually use. I hate MDF. This could probably be used in a project. Let's see, standard switch, toggle switch. And impossible to remove. It might have been crimped on there as well too. So I'm gonna cut that off. So maybe I'll use this in another project. It's probably fine. And it's also, looks like it's waterproof or something because it has a nice protection around here. So this could come in handy sometime. I am a hoarder of these types of things. I used to get components from Houston Recycle when I lived in Houston, and it was just like stuff that people would leave on their porches, and I would just take these. I would take every component that I could find, and I would just desolder them. I had a lot of fun with that, but I probably did a number on my lungs with all that flux and chemicals. So this, let's see, there's not much here. There's this is probably an inductor of some sort. So it's just using the standard 60 hertz probably to spin this thing. There's only one speed on or off. A couple capacitors to smooth out the waveform. There's a bunch of, oh, this is a I guess, a poor man's rectifier. So we have 4 diodes. 1, 2, 3, 4. And what they do is they take the AC, but that means that this would have to be a DC motor and not an AC motor if they're doing that. So they take this, they're taking this and they're bringing all of the waveforms on the north side of 0 or positive volts. And I'm guessing, I mean, they're not doing much with the stabilization of the waveform itself, because you'd have to have pretty big capacitors for that. But I'm wondering what this is. It's probably an inductor. I'm thinking it's an inductor. And this is a what do you call it? Transistor, probably. Although there's other things that come in the same package. It looks like a transistor though. Yeah, Houston definitely did a number on my lungs, for sure. Yeah. All right, this is a good little icebreaker for the live stream. Taking apart a Ryobi. Oh, look at that. Wait, where was? Oh yeah, this was right here, wasn't it? This is what. Oh wait, this stuff was probably only for the LEDs. So the rectifier was probably just giving the DC output for the LEDs, and this probably brought the voltage down. Maybe the transistor probably helped that as well. It'd be interesting to look at that circuit, but pretty simple circuit for just putting on an LED, and then the rest of the output probably just went straight to the motor. So it is probably an AC motor. You can see just these went straight out to this inductor, it looks like. Let me see if we can get a better view of it. So we got these inputs. Yeah, it's going to the whatever this component is. At least this one is, and then this one goes to the other end of that component. Yeah, maybe a little like a mini transformer. All right, and then we just have this, the cord. It's a capacitor. This is a capacitor. So really, all it's doing is it's smoothing out an AC waveform. Then probably making it more like a nice clean waveform rather than that messy thing that we saw the last stream. It would be kind of interesting to look at the waveform in an oscilloscope, but I'm afraid to put AC anything on an oscilloscope. Look at that, a nice cord that I'll never use. 2-prong cord, like all routers seem to have. And here are the brushes. So you'd have to do all of this to get the brushes out. There are a lot of other routers that you just take, you just remove a couple screws on the side and you can just remove the brushes. I think these are the brushes. A dropping capacitor. Oh, okay. I'm not seeing the whole chat. Let me fix that. Yeah. So this capacitor acts like a resistor. My AC knowledge of electronics is very, very limited, like embarrassingly limited. Let's see if I can just pop this out. Not with this. Maybe from the other end. Oh, there go the rest of the ball bearings. Oh yeah. It doesn't come out that way. It comes out. Oh yeah, there's a little spring in here. Obviously, there's springs in the brushes, but getting them out. No, they don't come out. So this is a disposable router. You can't just replace the brushes. Okay, so a cap dropper circuit is a type of transformerless power supply converting AC mains inputs to a much lower voltage output. The windings would work well under, I guess, for this specific, I guess, number of windings on the armature. Oh, by the way, welcome, Skeptic. Thank you for coming in. I can't read that, unfortunately. Sorry, webmaster. But if anybody wants to translate that, feel free. I gotta tell you, when I was a kid, I used to do this to everything. So this is going to be the main winding, or the main, I don't even know what to call it. Yeah, the other side of the windings. So we got a good bearing on this side, but a destroyed bearing on this side. This is a larger bearing too. Where is that race that I had? Oh, there's. I don't think this is a seal, or is it just a shim washer? This is probably a seal. Looks like it's a seal. Okay, it has nothing to do with the windings. Okay, interesting. Yeah, I don't know much about motor windings and that sort of thing. But where is the? I lost the outer race of the bearing. Okay. Well, it doesn't really matter. Probably dropped on the floor. Well, there you go. A fully taken apart Ryobi. Any questions or any surprises? This could actually be brought back into use if I have some kind of way to keep these two bearings in stable, but this is generally just going to be just all right. Let's get back to shielding. I'm still looking for that race. All right. Yeah, maybe I could turn it into a blender. Or are you asking, will it actually blend in a blender? Hey, Marty. Thank you for coming in. How are you doing? All right, where we left off, now that we have more people in the chat, we have a bunch of questions. First of all, there are a lot of things that I don't know why it's happening with the EMI. And I'll just go over real quick. The experiments we did last week on shielding, I think it was the first video we had on shielding. I had a smaller conductor, a shorter conductor, and I was using it. I was measuring interference on that conductor from the router, this router specifically, and it was the one that I ran this thing quite a number of times. We found a lot of spikes on that, in that condition, and I'm very perplexed why we're not getting any of those spikes now. And we have a longer wire. And my thinking is that the AC, because that had a lot of voltage peak to peak on this cable itself. So maybe that was overpowering any spikes that we're getting from the router. So let's just do that real quick. Let's just run the router and test look at it on the oscilloscope, just to get a reminder of what the condition was. And what I want to do in this session is also test it. Well, I've already tested it with this wire, and we did see a lot of interference from the motor. In fact, there's a lot of interference on this motor as compared to the router. So any preconceived notions that we have with this being a worse, I don't know what the word I'm looking for is, a worse device, I guess, that would offend. One would think this would be the worst offender, but in the experiment so far, this is the worst offender. But in this session, I would also like to connect it to the controller and see if it trips, because we haven't really done that yet. See if it actually trips in Mach 3, if it trips a reset when we have it connected to a switch, a limit switch. So that's what my goal is for today. So I'm going to aim for that. And if anybody has any suggestions on any tests we should do in the interim, let me know, because I think there's probably more we can do to seek EMI, just not really sure what yet. So I'm going to kind of use that as my goal and see what comes of it. Yeah, the webmaster is saying permanent brushes for a long-running CNC milling machine. This is very bad and not for long. Absolutely, I completely agree. That's why I recommend using spindles. Since I got spindles, I've been able to run CNC machines or the spindle for years rather than months. I have used these types of routers, the 3 horsepower routers on CNC machines when I first started back in 2007, 2008. 2009, and I would get maybe, like from this router, I'd get maybe 6 months out of it, and it would just go, it would be gone. A DeWalt, I tried a DeWalt. I thought they were really good, high quality routers, but the one that I got lasted about a few weeks under the loads of using CNC machines. So that was bad, and I had to continually buy routers over and over again. And then I finally made the switch to spindles. And the spindle that I have on my machine right now, I've been running it for about 5 years, and I hear no difference from when it was brand new. It's quiet. It's really nice. The other thing is I'm also going to be getting into the Spinology spindle that I have over there in a later set of videos. But I need to get a different VFD for it. I want to get a higher quality. I'm going to be purchasing a Siemens VFD, and I'll be putting that together and interfacing that spindle with the Siemens VFD. And also, I will be interfacing the sensor outputs, probably first to an oscilloscope, and then potentially to a project with the microcontroller. I introduced the Spinology spindle, but I want to do more with them. I eventually want to design a brand new machine, and I'm thinking a 5-axis machine, something relatively small, maybe a 3x3 or something like that, 3 foot by 3 foot, or I can't even tell you how many millimeters that would be. But I want to design that with the Spinology spindle. So I'm going to be taking my big machine apart that is over there, and that one is my workhorse. That one has been used for many years, and I had one prior to that which was being used for probably 5 years before that. So, and I also have customers out there that are still using their machine that's pretty much like that. But because I like to tinker and I like to do projects, I'm constantly wanting to design a new machine all the time. So I'll be doing that during the streams, and I'll be using a Libre software to do all of the design. It'll be ball screw driven. Not sure how to do the 5-axis part yet, but that will be an exploration. I don't know if I'm going to use something off the shelf or build my own. Not really sure yet how to do that. And that's going to be something that's going to be fun for me to try to figure. All right, let's get back to this. So let's go ahead and look at what this was again, so we can remind ourselves. I'm going to see if I can get this all in frame. The ball screws, I don't know yet. I'm going to be looking at, Bob is asking, where are you going to get your ball screws? I'm going to try to get it from a German source. I had a couple ball screws that I unfortunately let go of, and that was from a $1 million laser machine that was taken apart that I was helping out. But I'm going to get whatever I can afford. So I don't know if I'm going to get the Chinese version or not, but I would rather get something higher quality, especially when I'm working with the Spinology spindle, because I don't want any play at all with that spindle. So I'm going to try my best with the limited knowledge that I have. Okay, so I can probably get this in the frame. Let me move this out of the way. And before, I actually still have it. I have the probe on the other end. I don't think you can see that. Yeah, I have it at the other end of the cord. So right when I plug it in, you should see a sine wave show up. Yeah, I'm going to do the entire build of the machine on live stream. So, and if it takes longer to to design this machine, I might do live streams that are longer and longer form live streams. Like maybe I'll extend it to 4 hours instead of 2 hours, because it's going to take a little while to do, obviously. And this isn't powering up. I probably have it unplugged. Nope, it's plugged in. Oh, I don't have it plugged into the wall. Also, I think this is kind of an interesting way to measure AC signal on an oscilloscope without having to deal with the dangers of the ground being, because the ground, these are connected directly to earth ground. So there's a potential for shorting, and all of the information I've seen on the internet, I don't want to get close to that, get near that kind of stuff. So we have it plugged in. We should already have a signal coming out. Yeah, you can see. I'm going to make it a little bit bigger. Let's see what the peak to peak is. The peak to peak is, it's about 2.6 volts peak to peak. I'm going to bring the trigger down here so we can see what the waveform looks like. So even though this is going to be a 24 volt signal on this line, because this is this is on the outputs for, or actually on the inputs for these controllers, it's a 24 volt input. You could use 12 volts, but it's recommended to use 24 volts. So this would affect that 24 volts by 2 volts by itself, just from the AC line. Yeah, Bob, you're asking about the cheaper ball screws. Yeah, I'll definitely do that. I have one, or I used to have them in stock, but they're the Chinese versions. They seem pretty tight. I just don't know what the load is. I have to find out, and maybe I can do some of those tests here, because they're so cheap that I can essentially break one and see what the loads would be. An axial load would be a really nice test for a ball screw. If with an axial load, you're also going to find out how much load you'd have on the transversal axes, because the balls are round and the grooves in the screw are round. So you would see any deflection in that respect as well. Okay, so this looks, this is 2.52 volts peak to peak. And it's weird, it's kind of like a jackknife, or it's a saw blade type of waveform. It doesn't seem like a nice sine wave, but I guess if I was looking directly at an AC line, the waveform would be much different. I think just because of the fact, there's also another waveform in here too, because of the atmospheric, and that might be at a different frequency. Let's see what that is. You know what? Hold on a second. Never mind. This is the atmospheric signal. This is not the signal on the AC line. We're about to find out something, even a worse offender, I think. All right, so I'm going to plug it in right. I'm not looking at the screen right now. So now it increased the peak to peak to 5.44. Yes, it is. It's got some different. It's got like a sub wave. It's got a different frequency wave in it. And I would have to try to eliminate the main wave to be able to see that smaller frequency, but it's regular. So we could probably count how many ripples there are in this. Let me see if I can get in here. So from peak to peak, I'm going to count this second one, then I'll go to the last one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's 10 times 60 is 600. So there's something that has 600 hertz in the atmosphere somewhere. But it's a very small wave, so not a big deal. But 5 volts, if you're running a line next to an AC line, sort of a delicate line for a limit switch, 5 volts will affect a 24 volt, because that's going to be at the 0, it'll be like 2.5 volts, 2.6 volts, and at the other end, at the 24 volt high signal, it'll be another 2.6 volts, bringing it down. That doesn't, I don't think that doesn't really get into the no man's land of where a controller can't understand the signal, but it's definitely something that's contributing. That could be, that could cause a failure because of other things adding to that. That sine wave, Bob is saying that sine wave is from a filter with overshoot. Yeah, I don't know what that means. That is terminology that is very foreign to me. So if you can give me an elaboration on that, that would be awesome. The probe is connected to the other end, and I'm going to connect it to the near end. The probe is connected to the far end because that would be normally closer to where the controller would be. But I'll connect it here and see what happens. It's probably going to be the same thing, I would expect. Okay, so I took it off. Let's see what just atmospheric stuff is. So there is just on the probe itself, there is an 18 millivolt. That's the same pattern and the same frequency, it looks like. But it's only 18 millivolts peak to peak. So I will bring it to the other end here. And there we go, we got another one. Okay, so the peak to peak is 5.48. It's the same as the other one. Yeah, I know, I'll look it up. Yeah, I'll look that up. A filter overshoot, I'll look that up myself to learn a little bit about. All right, so we see something here. Should I go ahead and connect it to the controller, or should I do more tests? And if you temporarily turn off the power to the LED lighting, will the leads disappear? The LED lighting from what? Oh, from the fluorescent? Let's see. I'm guessing you're talking about fluorescent lighting, my overhead lighting. It's still there. The same condition, it exists. So the fluorescent lights are not causing any of the signal, but this is good. I'm liking that I'm getting something. So let's turn on the router and see if that changes. I'm going to bring this down to 2 volts, 5 volts per channel, and I'm going to bring the trigger just above that wave, that sine wave. It looks more like a sine wave here, doesn't it? All right. So I'm going to go ahead and start up the router. And I'm going to do it in 5 seconds so you guys can be prepared. 5, 4, 3, 2, 1. We saw something. That was good. So we saw it because I think maybe it's because this is located here and not on the other end, because we didn't see it at the when it was on the other end. Let me try putting that on the other end again and see what happens. All right, let's try it. 5, 4, 3, 2, 1. Okay, we definitely got something. So it doesn't matter what end. Why didn't we get this last time? That is interesting. Bob, you're saying no change, but I saw it. I saw the, I guess you're referring to this condition. I did see this freeze, so I guess there was a little bit of a, I didn't see anything dramatic like we saw in the first video. Like there was a huge spike that happened in that first video. I'm going to bring the wave a little bit tighter so we can see maybe a spike go across. Yeah, no change with the lights for sure. Okay, so let's see if we can find an actual spike. Okay, so this is 5 volts per division. Let's try it again. Okay, 5, 4, 3, 2, 1. Now you're not going to be able to see it in this condition because the waveform looks the same. I don't think there's any spike. Let's see if there's a spike way up here. This would be, let's see, this is 5, well, hold on, the wrong one. So this would be 5 and then 10 volts. So if it gets into the 10 volt range, it's definitely going to trip the limit switch. 5, 4, 3, 2, 1. Nothing. I'm going to go down to 5 volts. So that would have to, if the peak to peak is 5 volts, it would have to go up to about 7 or 8 volts to be able to, peak to peak I mean, to change. 5, 4, 3, 2, 1. I'm going to change the RPM and see if that makes a difference. I'll just try this once. 5, 4, 3, 2. Okay, there was a spike. So there is some interference and it's happening at 60 hertz. So there's a spike like right here. It's offset from the actual waveform. All right. Hey, CNC time lapse, how's it going? All right. So what a patient cat you have. He's not afraid at all. He's very very accustomed to this environment because I run the CNC machine every now and then, and he still stays here. He's fine. The cat has definitely seen some things. All right. So unless I have any objections, we are only seeing very small spikes, so I am going to go ahead and connect it to the controller. We already know what we're seeing on the motor, and the motor is worse than the AC line. Wait, was it? Does anybody remember what the peak to peak was for the motor when the motor was running? Right, the load. That's going to be a hard one to test. Any suggestions? Should I put a piece of wood there on the like when the thing is running? Maybe put a piece of wood to simulate some kind of load? It could be a little dangerous, but danger's my middle name. Or I could stand it up like this and run it and then bring it to the, I mean, I don't really care about this router. I can break it. I don't really care. So what would you suggest? Let's try something really dangerous. Yeah, it does sound dicey. Hey, R, thank you for coming in. Welcome, and how you doing? Yes, where's a volunteer? Bring a volunteer on. Let me get a piece of scrap wood here. There'll probably be a little bit of smoke, but I don't care. I'm going to try to put it in a way that you can see it. It's a piece of wood that I used for, this is a holding tab, by the way. All right, let me get a couple clamps. This is for science, right? I mean, there's really nothing to catch here anyway. It's just going to create like a small, maybe a divot here, wherever I plan to put it on. All right. Yes, have EMS on standby. If you had a router table, you could strap it in and feed it a piece of, I could do that, but it would take too much time. Yeah, it would be preferable. Webmaster, it is better to let it lie on the table, hold it with your hand, and press the piece of wood on the side. Okay, let's do that. Yeah, and it's supposed to take side load anyway. It's not really supposed to take axial load. So that's a good idea. I'm going to do that. But I want to do it, let me think if I can create sort of a hinged type, because I only have two hands. So you're saying something like this, although I want you to be able to see the... So I guess I could turn it on and then I can just press it down. And let's see, which way would it go? It's going to be turning in this direction. I wouldn't want to have it underneath like this. That would be dangerous. So I'm gonna opt to do it just like this. Although this is a spanner flats here, so that could get kind of dicey as well. All right, let's just do it. All right, let's see if I can get it all on video. If you hear screams, you know what to do. I mean, you guys told me to put load on it. All right, so a disclaimer, don't try this at home. I'm doing this on my free will, and I was not coerced. Let's see. Clamp the motor down on its side and then lower the wood onto the side of the collet. I'm afraid you won't be able to hold the instrument in your hands. I think I'm going to be fine. Famous last words. All right. So I'm going to turn it on in 5, 4, 3, 2, 1. Why am I not getting... Oh, it's not connected. I have to connect the lead. That would be stupid to do this and not have a lead connected. All right. R. Maury, thanks for coming in and witnessing a potential mishap. Kitty might need to eat you to survive. That's what they do, right? When everybody dies and they're not fed, they start to nibble on your nose. You know what? Should I wear gloves? I don't want to wear gloves. Gloves are generally not a good idea anyway for this. All right, I have a good hold on this. Let me make sure I have a good... Okay, I can smell burned wood, and I didn't see the spikes exceed the peak to peak. And I repeat what Bob says. Disclaimer, do not take action or refrain from action based on anything you see and or hear from this video, for sure. All right, yes, clamp it down first. I didn't clamp it down, and it was fine. It was actually fine. I was actually able to press it down pretty hard, and I thought I was gonna break the wood actually. So let's see. You can see the mark here that I was definitely putting some force on it. So that is with load, and I'm convinced that the spikes from a router is not going to affect, at least be worse than the AC. At least in this condition where there's a tri-state condition, a tri-state condition where there's just a conductor alongside an AC cord that ends at a router. I do remember seeing something worse before, but maybe it wasn't really that bad, and I had this turned up to I think 200 millivolts per. Oh no, it was 200 millivolts per division. All right, yeah. So CNC time lapse, that is kind of freaky. No movement on the waveform either. Our spikes got worse under load. It did get worse, but it didn't. I don't think it got any worse than the existing. Let's go bigger. Let's make it so we can see a lot more of the waveform. And let's do the same experiment. I'm going to try to use the same part of the wood because that's going to give more of a circumference. It'll cover more of the circumference of the collet. This is kind of warm, not too bad though. All right, is everybody ready? 5, 4, 3, 2, 1. It didn't get over the waveform. It got pretty close to the crest, but I don't think it got all the way up to it. Did anybody see anything different? Because I was trying to watch as well as I could. Oh, thank you, time lapse. Man, that is so nice. I really appreciate that. All right. Oh, the chat is getting away from me. Hold on a second. I'm gonna make it a little bit smaller so I can see everything. Okay, so our capacitive coupling going to be worse for spikes. Higher frequency than a 60 cycle sine wave. We can try the 100 microfarad like we did last time. It pretty much smoothed it all out, so we can see what happens with that. But still might not make a difference. So yeah, let's try the capacitor in this case. The skeptic, change the time base. Less time per square to capture high frequency spikes. Here, you're gonna have to help me out with that. So if I'm not mistaken, this is the time base. So it's the 100 seconds to 5 nanoseconds. So we should do something like this. And then we can also bring the trigger up. But I tried bringing the trigger up before and it didn't really make a difference. But I can try, like, right now we have it at 2 volts per division. You can bring it up to maybe 4 volts and see if we see something. Definitely, the spikes have slightly increased the amplitude. Yes, I saw it from Russia. It's nice to be able to do that. I remember using CompuServe. It took a long time to get anything. The knob under the blue button. Yeah, this is the one. Right, okay. The point UF ought to do the trick. I'm still a proponent of that capacitor. We can also do both, but I can also try another 0.1 UF. Let's do the 0.1 UF first. I feel like I'm doing this all over again, but it's worth the time, I think. I mean, we are kind of recording the scope, but I can, on my next, like on Tuesday, I can plug this into I can plug this scope into the, in the computer. I can extend a USB cable to the computer and show the output on the actual screen. I think that would be nice to see, actually. And I'll be able to see it better too myself. All right. Oh, Azil, thank you for coming in. How you doing? Much appreciated to have you come by and see what dangerous stuff we're doing. All right, so I'm going to keep it at that. We'll do one more test with the higher time frame. It is really difficult for you to see what is going on, but I'm just going to lower it real quick. It's just kind of flashing all over the screen. This is what we see, but it's just kind of all over the place when I bring it up to 4 volts. So I'm going to bring it up to 4 volts and see if we see this waveform, some spike happen. And I'll also do the test with low. See if I can get it all in frame here. All right, here we go. Okay, that was conclusive. I need to go a little higher on my trigger. Let's go 2, 4. Let's go 5 volts. Okay, so less per division. All right, so let's do that. Let me go bring it down. Okay, so you can see that. Well, I tried this before, but we didn't see anything. But I will bring the. Wait, where is my trigger? Here it is. My trigger goes away when I do it this way, so I'm going to have to keep it at this level here. So this was 2, 4. I'm going to go 5 volts because we definitely saw something at the 4 volts. So let's go 5 volts. By capacitive coupling, I just meant the noise that transfers from the one wire to the next through the shared capacitance between the wires. Yeah, we can test that. We only have a single wire right now, so the capacitance we're seeing is the dielectric between the conductor and the AC cable connected to the AC. All right. Okay, so let's try it again. See if we can see any spikes going on here. I think it was easier to see when it was more like this. So I didn't really see any spikes going on there at the tighter time frame, tighter frequency. You do it. Thank you for coming in. How you doing? Hey now, got you on the big screen today. Nice. They say people watching YouTube instead of traditional TV. They are right. Yeah. We're doing lots of dangerous things right now. I'm putting load on a router to see if the load affects the signal. And what we've found is load definitely does. And it seems to be getting, the load seems to create a spike that does get up to about 4 volts. So plus or minus would be 8 volts. So the peak to peak is actually 8 volts. So I'm going to do the test again at 4 or at 5 volts right here. Yeah, I wasn't able to see anything. I was hoping to see like a spike happen, like a spike, and you would see it for like a second or so. And that was my idea from the initial time I did it. But I'm just not getting the spikes that I did in the first one. Maybe because the router hasn't been used in a long time, I was getting spikes. So this would be more of a practical application. So I have it at 5 volts. Let's go ahead and do it with 5 volts. And I'm about to run. You can see I'm already pretty deep here. It's a beautiful smell of wood. By the way, this, if you don't know, this is MDO. It's medium density overlay. And this is used in the construction industry for concrete forming, and it's reusable. So even though it gets a lot of moisture, it gets completely saturated. The mechanical properties do not change. The dimensional properties do not change. They use this for outdoor signs, and I love this material because all of my machines are, or not all of them, the wooden machines that I make are made of this material, and the wood in general has a lower coefficient of linear expansion than plastics and metals. So it's actually a pretty good material to use for like CNC routing and stuff like that. Nothing serious like machining, because you have to have much better tolerances. Okay, so you can see that. I'm going to put it in frame or in focus. All right, let's see if I miss anything. Skeptic, yeah, we already got that. Hey there, Bob. Howdy. Yes, there are bursts, but they are very short-lived. The bursts are what I'm afraid of, because that will turn a CNC machine off. That will put it in reset mode. So it doesn't really matter how long the burst is. If it is, even if it's short, we want to get rid of it. And that's what we'll be doing, because this is really just these are experiments to try to seek out EMI in the worst case scenario or conditions. So Armory, if you want to see more visible difference, wrap your signal cable around the power cable 3 to 5 turns. Okay, I think I may already have it wrapped at least a couple times, but that's just that will enhance the AC signal. I don't think in any scenario we'll have that in a CNC machine unless somebody wants to attempt to manage their cables in some way. But I can definitely try that. Try pressing stop, then acquire to capture fast spikes. Stop on the oscilloscope or stop on the router. What material do you most commonly mill with your machine? The same material, the MDO. And I also do HDPE and aluminum. Skeptic, where is it showing auto? It should show up. Okay, so it is on the oscilloscope then. All right, so let's see. I have a run stop here. You can't see that because I have the camera. So I have a run stop. Is this the run stop you're talking about? Okay, so by pressing the stop, we'll be able to freeze the frame. Is that what you're saying? At a low camera frame rate, the spike was more noticeable due to poor frame change, and the magnitude of the spike as wheel. Okay, single shot mode. All right, so when I do a run and stop, okay, so that will freeze. That will freeze. So when I press run again, it'll continue going. And I stop, it freezes. Okay, so that could capture, but I need 3 hands to do this. because I'm going to be pressing down on the collet at the same time while I'm running this. I won't be able to press the stop unless I have somebody else coming in here. Okay, so if there's a single trigger, the trigger is here. There's a trigger menu. I can set it to 50%, force trigger, and set to 0. So I guess setting to 0 is just bringing the trigger down to 0, I'm assuming. Okay, let's press acquire. Okay, so sample, peak detect. Let's do the peak detect. Yeah, that'll work. And let's, should I bring it down? I should probably bring it down, shouldn't I? And does a trigger menu, oh, does a trigger even matter in this case? Well, let's try it. Press acquire, it'll be automatic. It'll trigger when the voltage peak gets high enough. Okay. The single shot trigger will capture it. It will capture when it triggers. You're back in auto. Well, I have it in peak detect. This won't do anything for me, or will it? Let me see something. I can't see my whole screen. There we go. I mean, I could try both, I guess. Let me try peak detect first and see what happens. I'm learning. This is the way to learn for me. I like to do this. I like to do trial and error. That's how I learned programming, actually. Yeah, it did. The surge did slightly exceed it, but I'm also interested in like an initial peak and an initial spike that we saw before, because at startup you're getting the most torque, I think, the maximum torque, I think, or a spike in voltage for sure to start the motor. So there should be something. So let me just do it by itself. I'm going to turn it on in 5, 4, 3, 2, 1. All right, I don't know how to use this, so I don't think it worked. So I'm going to go with the acquire like you were talking about instead. All right, so I have, on the trigger menu, I have acquire on the top. So if I use acquire, well, I should get out of my, out of this mode here. And there's also auto scale too. All right. So that was a trigger menu. This is a trigger menu, type edge, source, slope or rising, trigger mode auto, normal, single. I could try single, trigger mode single. Would that capture what I need? Yeah, trigger mode, skeptic, change it. Okay, so I got signal here. Okay, nice. Webmaster, to combat interference from wires, wrap the wire with foil, and you need to, yeah, this is, Webmaster, this is we are getting to that. That is going to be farther down the line, because right now we're trying to find the sources rather than trying to eliminate it. These are sort of experiments to first find the EMI and see where EMI will be located, on what devices and in what conditions. We will definitely be getting into the foil, because I have shielded cable that already has foil, like this cable right here. This is the shield, and within this there's a foil. It's not braided, it's just a standard foil. So we'll be getting into those. We'll also be getting into the braided stuff later on too. All right, so let's try this single and see what happens. I have no idea what to expect, so let's see. Unfortunately, there's a little bit more glare on the screen. Let me see if I can get rid of that. Okay, that works. Nice. All right, so it's in single trigger mode. So what will happen when I do that? 5, 4, 3, 2, Armory. What you seem to be testing it for is common mode or net common mode current. It would be better to have a small Ryobi coil. I have no idea what that is, but we will. I'll look into it. But if you're suggesting ways to eliminate EMI, we're not there yet. We'll be getting there. We'll be going there. Right now, we're looking for it and seeing what devices have it. It is stopped. So what do I put it in? Do I put it in acquire? No. Let me go back to the trigger menu. Okay, so we have trigger mode single. Okay, so run. No. Does it have something to do with this? No. So I pressed run and it's not doing anything. So I have it in slope rising. Oh, I'm sorry, trigger mode single. And auto is just as it was before. Normal, single. Okay, I'll run the router and see what happens. Okay, 5, 4, 3, 2, 1. Okay, it's definitely not doing it, so yeah. It will update? All right. Well, let's see if we have, maybe if I put the trigger down here. Oh, look at that, it does update. Okay. All right, let's try it. It moved when I brought the trigger down. 5, 4, 3, 2, 1. Yeah, I'm not able to capture a spike or anything like that I know of, unless I have it way up here, but it would just flash on the screen very, very fast. I'm looking for a spike right when it turns on. Those spikes we already know about, so I don't think we really care about that anymore. I am interested in it, seeing how high it can go with the load, but I think we did test that and it was up to 4 volts. 5 volts, did it get up to 5 volts? Drop the trigger down. Yeah, I did that. Once it triggers, it stops. Okay, well let me try this. Let's go back to single and I'll drop the trigger while I have the motor on. Okay, that's good. So it froze the condition while it was on, but it's still, I'm not going to be able to capture the initial spike. That's the only thing. But this is pretty good to know, actually, to see this as a captured waveform. All right, so what next? Do you want to see a 0.1 UF capacitor? See what that does? .1 UF. Okay, so the Ryobi coil will replace my probe. If you're looking for the source of EMI on that motor, it will come from the brush wires. Change nothing and start the router. Okay, let's do that. I think I did this before, but it doesn't change. All right, ready? See if I can get it better. No, that's as close as I'm going to get. Okay, 5, 4, 3, 2, 1. Now, it doesn't change. That's just the captured. So if I take it out, I know it'll probably release. Now if I go back down, no, maybe I need to press run again or something. Okay, it changed. Same thing, when I press run, then that acquires it. Yeah, so there you go. Yeah, I just did that. It is in stop, you have to run it. So I pressed the run and that's what happened. Okay, let's do that. All right, raise the trigger. I'm gonna raise it up to 2 volts. I'm sorry, 5 volts. Let's go down. Let's go to about 4 volts. All right, let's do it. But I don't think I'm gonna get an initial trigger. Let's press run. Okay, yeah. Okay, I'm getting what you're talking about. I'm understanding. Let's go a little higher. Let's go to 5 volts. 5, 4, 3, 2, 1. Sorry, I needed to press run. 5, 4, 3, 2, 1. Okay. There we go. All right, we got it. All right, let's do this a few more times. This is good. That is the way to go. All right, so now I learned a little bit more about my oscilloscope. Thank you for helping me out and guiding me. All right, so it looks like we have up to 10 volts. So that will be bad enough to trigger a reset in the control. Let's see if we can get a bigger, what do you call it, spike. And I want to see if there's a spike at the end as well. So let's try turning it on and then I'll press run again and then turn it off. I'm going to go a little bit higher. Do I need to press stop first? Or reset or something? It doesn't tell me if I'm in run or not. Maybe there's a way to... Maybe there's a way to acquire... No. I'm trying to get rid of this one because now this is stuck. All right, if I press the single again and go back to single, maybe that'll work. All right, let's try it. Press run. Do I have less time to do it? I can't repeat the process. That purple text. Okay, it tells you the mode at the top middle of the screen. All right. It says ready. It says stop. Okay, nice. So it's ready now. Is it in waiting for you to press stop? By the way, I apologize by turning this on and off without... Okay, this is auto. Now it's ready. Okay, 5, 4, 3, 2, 1. Just to see, just for a sanity check. Maybe I'm not going to get a... All right, so it says ready. Okay, I just wasn't getting the spike. That's why it wasn't reproducing. So yeah, now it says stop. So I'll have to press run again and it's waiting. So that's really good to know. So let's do this like 5 times. I want to go up to the 10 volts. Well, a little bit, just shy of 10 volts. And let's see what we get. So I'm going to press run. It is auto ready. All right, so I'll go now. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. That worked. All right, so it looks like it went up to 10 or almost 10. Let's bring it up a little bit, just above 10. Press the run again. It's in auto. It said ready. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Five, 4, 3, 2, 1. Did you hear how it ramped up a little bit at the end? I think it's trying to maintain its RPM, and it's not able to get there until, or for many seconds after you turn it on. Okay, one more time. 5, 4, 3, 2, 1. Okay, so this is the worst we've gotten so far. I would say it's about, it isn't, I guess I could use the cursor to measure it, but if this is 5 per, it's just under 10 volts. You can't see that very well. Yeah. So it's just under 10 volts. So that's significant. All right. What next? Controller? Or should we do the motor and try to get some readings from the motor cable? Or do we want to do more experiments with the router? Let me read all of your comments. I think it means waiting for a trigger. Yeah, that was crazy spike you got a minute ago. It's on the live stream playback for review. Yeah, got great spike there. There, got it again. Yep. It's just going to come down to luck of the draw, how big of a spike you get, by the way. Well, because with the commutator and brushes, yeah. Now decrease the time-based tick. Decrease the time-based tick. All right. Let's try that. Time-based tick. Okay, so it's only getting that number of samples, so I guess I'll have to run it again, obviously. So how much do you want me to change it to? Let's see, what is it now? I can't really see. So, hold on. I'm going to see if I can give you also the numbers on the bottom. So this is the time here. It's at 5 milliseconds. This is at 2.5 milliseconds. So what are you thinking? 10 milliseconds maybe? Or do you want me to take a look at this more of a wider view? Is this what you're talking about? This is the worst actually right here, the initial. So this is decreasing it. So you want me to go higher or lower? Go to 10 milliseconds or stay at this level? Okay, let's go look at the period of the spikes. Okay, so I will go to, we had it at 2.5, this is at 5. So let's take a look at this. It is still in ready mode, so I'm going to bring it just south of the 10 volts so we can try to trigger a spike. Okay, ready? 5, 4, 3, 2. You know what, if it's like down here, we're still going to get a spike. So let's see if we know that we have a 10 volt spike there. 5, 4, 3, 2, 1. I am going to turn it on while it's in decelerating. So I'm going to try that and see if I can get a spike. That wouldn't work. Okay, so I'm going to try it again. 5, 4, 3, 2, 1. Yeah, I'll do that. Bob, I will definitely do that on the spike. Oh, I got one. Oh my God, look at that one. Let's take a look at this one. My arm is in the way. Okay, we're not going to find much of a period. Oh, this is the transient response. So this is the spike. The spike is all the way up to 5, 10. That's 15 volts. 15 volts. That's huge. That is really big. 15 volts is nearing the, I mean, that's beyond the midpoint of a 24 volt signal. We got something big. Yeah. This is like a treasure hunt. I love this. Shall we try a couple more times to see if we get a better spike, or should we go on to something new? I think this type of experimentation, we probably wouldn't be able to do enough of this, that it's so significant. Yeah, that would throw, no, it wouldn't throw, I don't think the controller would know what to throw. It would maybe keep its same state, but I would think it might throw a 1, depending on what else is going on around it. That is considered no man's land, so yeah, I don't know what would happen. That is a question. That is definitely a question to see what, but it would definitely, if it was like an active low or active high, depending on what condition, what state it's connected, it could throw a 0 if it's active high. It could throw a 1 if it's active low. I don't know what would actually happen, but that's the problem, because not knowing is a recipe for disaster. Okay, so let's see what the period of the spike is. We have it at 25 microseconds per division. So if I change the position of this, we have a little bit more than 25 microseconds. It's about 30 microseconds. So it kind of coincides with the 60 hertz. But that is not actually, that's the entire waveform. It's not just the peak. So the peak would be half of that, probably 10 to 15 microseconds. Probably 10 microseconds. It doesn't look like it's that. Wait, we have another. What changes this position? I don't see a dial for that. This is probably just 0. Yeah, it's just showing 0. Okay. From the period of the spike, you can determine what capacitor you need. Okay, interesting. So a 0.1 UF, what period would that be? Do you know, or does anybody know? These frequency spikes are dealt with using ferrite beads, if I'm spelling that right. Yeah, it's beads, B-E-A-D-S. I've seen it in printers, etc. Yeah, for sure. We can do more to, yeah, when we get to the point where we're trying to reduce the EMI, I'm going to introduce well, I want to do capacitors now. I'm kind of curious. But I'll do the ferrite beads. I'll do the, somebody said resistor in line. Obviously shielding cable. And also winding a coil of the same wire around a toroid. I want to try to do that as well. Yeah. So that's a 40 kilohertz signal. Okay. So what would calm a 40 kilohertz signal? What capacitor would do that? Z equals 1 over JWC. Yeah, I'm not doing that math right now. We could, I guess, later on. I'd have to know what that formula is first, though. Okay, so it depends on the resistance and inductance in the lines, right? Okay, so W equals 2 pi F. Okay, so 0.1 UF would shunt a 40K to ground, no problem. 40 kilohertz or 40K resistance? I mean, I could try a 0.1 UF across the, like we did last time, across the probe and earth. Yeah, it does have a ferrite core on it already, but the signal wire doesn't. Let me see. Actually, no, it doesn't. It has no ferrite bead unless it's hidden in this part of the cable or behind it. I don't think this is it. This just looks like a plastic, but there is nothing on the cable. I'll give you a wider view. So this is the cable, and this is the green line I have along the cable. And this is just a mess of cables. And there is no ferrite bead on it at all. So that would help things as well. So we can note that, that we can do the tests adding a ferrite bead also to the AC cable. This is a Porter cable router. It's a relatively high-end router. Yeah, I'm going to do the real world experiment. Okay, so that's what we want to do next. In circuit switch, for example, not the router. Signal wires, the router would have EMI filter, okay, to prevent the high frequency go back into the mains. A 0.05 UF. You want to do the I don't know if I have a 0.05 UF. I have a 0.1. I don't think I have a 0.05. Yeah, we have a triangle wave too, actually. So let's try the 0.1. Let's just see what happens. I hope we can get a spike. So I'm going to put the 0.1 between the probe and the ground, and the black ground clip over here. Now, where did I put my capacitor? I'll get a new one. Well, I have a quiz for you. Who knows what these are? Does anybody recognize this? All right, I'll let you guys ponder. Okay, 0.1 UF. One side to ground, and the other side connected to the same wire and the capacitor. All right, you can see there's a 0.1 UF. Yes, Radio Shack, very good. I bought those when they were going out of business. I mean, they have such nostalgic value for me because I used to live in Radio Shack when I was young, and I would go on to their Model 1, Model 3, Model 4 computers, and I would just program, and people would be behind me just watching me. It was like that was my little bit of fame when I was young. All right, I'll go back to probably 5 milliseconds. I don't think you really need to see the router, do you? We're not going to put any load on it, so I'll just put it straight to the screen. I wanted to show the router while I was putting load on it, so you guys can call the EMS if you saw something bad happen. Yes, they put those. That's where the electronic components were located, and that's where I put mine too. It just seemed appropriate, you know. I can have my own little mini Radio Shack in my shop. Oh, that's so funny. I still have several unopened bottles of Radio Shack etchant. Okay, all right, so here we go. I'm gonna go to change it to the other way. I will stay with 2.5. Let's do that, and I'll keep the trigger here because I want to try to get any. Actually, I want to bring the trigger down, give it the best chance. So the trigger is going to be right here because I have a feeling that the 0.1 UF is going to calm a lot of this stuff down. We'll see. All right, put it on run. Okay, here we go. 3, 2, 1. Actually, I'm not sure if we're going to get much of anything, so I'm going to go way down just to see what we get initially. I just want to see where we're standing. 3, 2, 1. Check that out. We don't get anything. Bob, you're a genius. We love you. All right. 3, 2, 1. You know what? I'm gonna bring it to auto just to see where we are because I have no idea. Yeah. Okay. We got pretty much nothing, just like we expected. Remember last time we put a capacitor on there and it calmed that down completely. The capacitor is at the It's between ground and the probe. We still do get somewhat of a. Let's increase the amplitude here of the wave. So we are going to still get something. Let me bring down the. There we go. So you can still see we got something there, but the 0.1 UF, like we found before, when we were doing this initial test, it pretty much zeroed out the signal. Hi.
Are you ready?
Oh, what time is it?
2:15.
You mean 3:15?
Yeah.
Okay. All right. So this will be the cliffhanger for next time. I have to go to the doctor's to have a general appointment. So we will stop it there. I guess we could ponder until Tuesday what's going on with the capacitor and what kind of tests we can do, because I want to take the capacitor off because I'm still looking for the worst case scenarios. This is one solution, but I also want to test this solution in circuit so we make sure that we still get a good signal between 0 and 24 volts when we trigger a limit. All right, everyone, thank you so much for coming by, watching, participating, and I am grateful like every time you come. So thank you so much for coming by.